Our project was to make a temperature control system which we use to brew beer. Brewing beer is a scientific process that involves combining water, yeast and beer ingredients into a keg of about 23 litres. This mixture is then left to ferment for around 2 to 3 weeks. Yeast fermentation slows down under cooler temperatures and speeds up under warmer temperatures. The temperature of the yeast directly affects the flavour and quality of the beer. Our objectives were to modify an existing bar fridge to be controlled by an Brewduino and be able to set up different temperatures for fixed intervals. This level of temperature control allows us to enhance desirable beer flavours. For example, lager beer requires that the keg be maintained at 17 degrees for 2 weeks, then crash cooled to 7 degrees right at the end.
We started with a bar fridge and an Brewduino. Our keg fits inside the bar fridge. We then have 3 temperature sensors, one inside the keg, one inside the fridge, and one outside the fridge to record the ambient temperature. The temperature sensors are connected to a 1-wire serial bus, so the Brewduino only needs one pin to communicate with the temperature sensors. Within the fridge, we have a compressor and a heater to control the temperature. Both the compressor and the heater run at 230 volts AC, and so they can't be controlled directly by the Brewduino. For this reason, we use solid-state relays to control the compressor and the heater. Solid-state relays themselves require more current than the Brewduino can deliver, so we had to use bipolar junction transistors to be able to turn the solid-state relays on and off. We also put a fan inside the fridge so that we could circulate the air and make sure that the temperature was well distributed. The fan runs at 120 milliamps and 5 volts, and so we also had to use a bipolar junction transistor to be able to turn the fan on and off. Initially, we wanted to connect the LCD display directly to the Brewduino. However, this was a problem because the LCD display requires 5 volts and the Brewduino only delivers 3.3. We managed to buy a level shifter which shifts the voltage from 3.3 to 5 volts so that we could connect the LCD display to the Brewduino. The system would not have been complete without some super bright LEDs. The LEDs that we used require more current than the Brewduino can deliver, and also have about a 3 volt forward voltage drop. For this reason, we use bipolar junction transistors to be able to turn the super bright LEDs on and off.
We found a fridge of a suitable size and began to make our modifications.
So I've taken this cover off. All these wires are tucked away at the back there, covered by this.
Get in there.
By this cover. I've taken it off, and we found this bunch of wires. The extension lead comes in, gives you an active, neutral and earth. The frame is earthed and the earth is sent up to the thermostat. The neutral is sent up to the thermostat and down to the compressor. And then the active is sent up to the thermostat and an active signal comes back, which is then switched by the thermostat and goes straight to the compressor.
We used a potentiometer to adjust the brightness of the LCD, which displays the current state of the finite state machine. These are the 3.3 to 5 volt logic level shifters. These are the BJTs we use to drive the super bright LEDs. The temperature sensors are all connected with the 1-wire bus. These BJTs are used to drive the solid state relays. All 230 volt equipment is kept at the bottom of the fridge for safety. Using water instead of actual beer, one test was to see how long it would take to get a keg of chilled water up to a yeast-friendly 28 degrees. A problem we encountered during these tests was that our initial algorithm was regulating the temperature of the fridge and not the brew. We found that the brew never quite reached the desired temperature or did so really slowly. We decided to change things up and redesign our control algorithm.
In order to cool the keg down, the fridge needs to be much colder than the keg. This is because the keg contains a large mass of water. When cooling, we keep the fridge temperature within the blue band indicated on the screen. Here, the ambient temperature is at 25 degrees and the desired temperature is at 21. The fridge temperature will oscillate around 11 degrees until the keg is cool enough. The brew has reached the desired temperature and so the fridge is no longer cooling. The keg will heat up only once the fridge temperature is greater than the keg. Here the keg is 1 degree above the desired temperature and so the fridge turns back on. The same applies for heating. Here is some of our recorded data.
Cheers!